functionalized carbon nanomaterials using graphene, carbon nanotubes, carbon nanofibers, and mesoporous carbon materials play an important role in the valorization of biomass due to the tunable porosity, extremely high specific surface area, and excellent hydrophobicity. This protocol demonstrates a general method to tune the acidity of solid acid nanosheet, modified platinum carbon nanotubes, for biomass valorizations.
Acidity of the solid acid can be modified by varying the number of defects, specific area of the carbon nanotube, and types of solid acid nanosheet, so that during biomass conversion, the catalyst can be fine-tuned to produce different products depending on different product requirements.
First, immerse 1 gram of carbon nanotubes, or CNTs, in 50 milliliters of nitric acid in a 100 milliliter beaker. Sonicate the solution at 25 degrees Celsius for 1.5 hours to remove surface impurities and to enhance the anchoring effect of the catalyst. Then transfer the solution to a 100 milliliter round bottom flask. Reflux the solution in a mixture of nitric acid and sulfuric acid at 60 degrees Celsius overnight to create surface defects on the CNTs. After cooling to room temperature, filter the solution to obtain the multi-wall carbon nanotube solid. Wash the solid once with deionized water. Dry the solid at 80 degrees Celsius for 14 hours. Mix stoichiometric amounts of lithium carbonate and metal oxides niobium oxide and tungsten trioxide in a molar ratio